Have you ever wondered why what goes up must come down? Why don't we float away into space? The answer is a fundamental force that governs our universe, gravity. Gravity is the invisible glue that holds everything together, from the largest stars in the cosmos to the smallest grains of sand on the beach. It's the reason planets orbit stars, why apples fall from trees, and why you feel firmly planted on the ground. Without gravity, our world would be a very different place. Imagine trying to play catch if the ball just kept going up, or trying to drink a glass of water in zero gravity. Gravity might seem like a simple force, but its effects are far-reaching and awe-inspiring. In this exploration, we'll journey together to understand what gravity is, how it works, and how it shapes our understanding of the universe. Buckle up, space cadets, it's going to be a fascinating ride. The story of gravity is often linked to a falling apple and a brilliant scientist named Isaac Newton. Now, whether an apple actually bonked him on the head is debatable, but the story highlights a crucial moment of scientific discovery. Newton, observing the apple's descent, began to ponder the force pulling it down. He realized that the same force acting on the apple must also be responsible for keeping the moon in orbit around Earth. This was a revolutionary idea. Before Newton, people thought celestial objects like the moon followed different rules than objects on Earth. Newton's genius was in recognizing a universal law governing both the heavens and our everyday lives. He called this force gravity, from the Latin word gravitas, meaning weight. Newton's insights laid the foundation for our understanding of gravity for centuries. His work explained why things fall down, how planets move, and even allowed us to predict the motion of celestial bodies with incredible accuracy. His apple-inspired epiphany changed science forever. Newton didn't just describe gravity, he gave us the mathematical tools to understand it. He formulated the law of universal gravitation, which states that every object in the universe attracts every other object with a force proportional to their masses and inversely proportional to the square of the distance between them. Let's break that down. The more massive the objects, the stronger the gravitational pull between them. That's why the sun, with its immense mass, holds our entire solar system in its gravitational embrace. The farther apart objects are, the weaker the gravitational force between them. This explains why we feel Earth's gravity much more strongly than the sun's gravity, even though the sun is far more massive. Newton's equations allow us to calculate the force of gravity between any two objects, whether it's you and the Earth and the moon, or two galaxies colliding in the vastness of space. His work provided the framework for understanding the movements of planets, stars, and even the tides on Earth. Pretty impressive for a guy who may or may not have been hit by an apple. While Newton's laws worked incredibly well for most everyday purposes, a few mysteries remained. Enter Albert Einstein in the early 20th century, with his groundbreaking theory of general relativity. Einstein took a radically different approach to gravity. He proposed that gravity isn't a force acting at a distance, but rather a curvature in the fabric of space and time itself. Imagine a bowling ball placed on a trampoline. The ball creates a dip, a curvature in the trampoline surface. Now, if you roll a marble across the trampoline, it won't travel in a straight line. Instead, it will curve around the bowling ball, following the curvature of the trampoline. Einstein argued that planets orbit stars for the same reason. They are following the curves in space-time caused by the presence of massive objects. Einstein's theory revolutionized our understanding of gravity. It provided explanations for phenomena that Newton's laws couldn't account for, such as the bending of light around massive objects and the subtle shifts in the orbits of planets. His work showed that gravity is not just a force, but an intrinsic property of the very fabric of the universe. Section 5. Gravity's Grand Dance, from planets to tides. Gravity's influence is everywhere we look in the cosmos. It governs the majestic dance of planets around stars, with each planet held in its orbit by the star's gravitational pull. Our own solar system is a testament to this delicate balance, with planets of varying sizes and masses gracefully waltzing around the sun. But gravity's effects aren't limited to the vast distances of space. Here on Earth, we experience its influence every day. The ebb and flow of tides are a direct result of the gravitational tug-of-war between the Earth, the Moon, and the Sun. The Moon's gravity pulls on the water in our oceans, creating bulges on the side closest to the Moon and the side farthest from it, resulting in high tides. Gravity even plays a crucial role in the formation of stars and galaxies. Clouds of gas and dust in space are drawn together by gravity, collapsing under their own weight. This collapse generates immense heat and pressure, eventually igniting the nuclear fusion that powers stars like our Sun. It's gravity's grand choreography that shapes the universe as we know it. Section 6. Weighty Matters, Gravity and You. Gravity isn't just something that happens out there in space, it affects you personally every single day. You feel it as your weight, the force with which the Earth pulls you towards its center. Your weight is directly proportional to the mass of the Earth and your own mass. Ever wondered why you'd weigh less on the Moon? The Moon is much less massive than the Earth, so its gravitational pull is weaker. If you were to stand on the lunar surface, you'd experience only about 1/6 of your Earth weight. You'd be able to jump higher and farther, but be careful not to float away. Gravity also plays a crucial role in keeping you healthy. It helps your body maintain bone density and muscle mass. Astronauts living in the microgravity environment of space have to exercise regularly to combat the negative effects of prolonged weightlessness. So, next time you're working out, remember that you're fighting against gravity to stay strong. Ready for some fun facts about gravity? Here are a few tidbits that might surprise you. Time flies when you're having fun, especially in stronger gravity. Einstein's theory of relativity predicts that time actually slows down in stronger gravitational fields. So, technically, time passes slightly slower at your feet than it does at your head. Don't worry, the difference is so tiny you'd need an atomic clock to measure it. Black holes, gravity gone wild. Black holes are regions of space-time where gravity is so strong that nothing, not even light, can escape their grasp. They are formed when massive stars collapse at the end of their lives, creating objects of unimaginable density and gravitational pull. Gravity waves, ripples in space-time. Just like a boat creates ripples in water, moving objects create ripples in space-time called gravitational waves. These waves were first detected in 2015, confirming a major prediction of Einstein's theory of general relativity. These are just a few examples of the fascinating and often counterintuitive effects of gravity. The more we learn about this fundamental force, the more we realize how much more there is to discover. Even though we've come a long way in understanding gravity, some big questions remain unanswered. One of the biggest mysteries is how gravity fits in with the other fundamental forces of nature: electromagnetism, the weak nuclear force, and the strong nuclear force. Physicists are searching for a unified theory that can explain all these forces within a single framework. Another puzzle is the nature of dark matter and dark energy. These mysterious entities make up the vast majority of the universe's mass and energy, yet we know very little about them. Their gravitational effects are evident in the movements of galaxies and the expansion of the universe, but their true nature remains elusive. Solving these mysteries will require pushing the boundaries of our knowledge and developing new theories and technologies. The study of gravity continues to be at the forefront of scientific exploration, with the potential to revolutionize our understanding of the universe and our place within it. Gravity is a fundamental force that shapes our universe from the smallest atoms to the largest galaxy clusters. From Newton's apple to Einstein's curved spacetime, our understanding of this force has evolved over centuries, revealing a universe far stranger and more wonderful than we could have imagined. But the journey of discovery is far from over. Many mysteries about gravity remain, waiting to be unraveled by the next generation of curious minds. So, keep asking questions, keep exploring, and never lose your sense of wonder. The universe, with all its gravitational wonders, is yours to discover. Did you enjoy this exploration of gravity? There's a whole universe of fascinating science waiting to be discovered. Be sure to like this essay and subscribe to my channel for more cosmic adventures. And don't forget to share your thoughts and questions in the comments below. Let's keep the conversation going.